Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron as sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Let's observe once again. If I'll press switch 1, counter is start. If I'll press switch 2, counter is stop. But here we can see, even we have pressed the switch 2, but the counter is running. It means that the program was in delay loop and we have pressed the switch 2 and the switch was not acknowledged by the program. So we have to press the switch longer than the delay which we have incorporated in our program, that is 0.5 second. Now program is stopped. If we'll press the reset switch now, counter will be reset. Again, start the counter, stop the counter and reset the counter. Now we'll write a program in which we will use a subroutine to produce the delay function. We will not use the command which is given in MikroC to produce the delay, that is a pause function or delay function in MikroC. The major advantage of the delay which we will write in our program is that our program will not stay in the delay and it will continuously execute each line which is written in our program. But in delay function, program stays in a delay, and in that delay function our device will not be able to execute any other command which is written in our program until unless the lapse of the time. Here we can see that delay underscore millisecond, and the number which is given in between these two brackets is 1000. It means that 1000 millisecond, which is equals to 1 second. We can find the complete description of this delay type and any other delay function which is given in MikroC through the help of MikroC compiler. Now we'll write a program to generate the delay routine using subroutine. For this we'll go for project, OK, new project, and we'll go for standard project, next, and the project name is counter delay underscore switches, and the project folder will be, and here we'll select the folder switch programs. OK. The device which we are using in our prototype is PIC16F877A and the clock frequency is 10 MHz. OK, next. OK, finish. And here we have our delay program, that is counter, delay and switches, and the program is starting from void main. So first we'll add some comments and assignments in our program. Now we'll assign the names to the ports which we are using in our program. Now we'll write the port assignments. For this, we'll write define LED PRT is the name of the port to which we have connected the LEDs, and the port is port B. So here we have assigned the name LED PRT to the port B, and here we will write port B. Now we'll define the name of the port at which we have connected the switches. So we'll write define SWPRT switch port, and we'll write here port D. OK. Now we'll write variable assignments, and here we'll assign the variable that is counter register. For this we'll write unsigned character, that is counter reg equals to 0. Here we have initialized the counter register. We can add the comments to our program to make our program more readable. So here we will add comments, that is counter register And now we'll write the bits assignments. And here we'll define a bit as start stop flag. So we'll write bit ss underscore flg, and we'll add the comments at this line, that is start stop flag. We can add more variables and assignments as per requirement of the program. Now we'll write our main program. And here we have our main program starting from void main. First we'll configure the ports which we'll use in our program as input or output. So here we'll write trace B equals to 0B 00000000. It means that all 8 pins of port B are configured as output port. Now I'll define the direction of port D. Trace D equals to 0B 11111111. It means that all 8 pins of port D are configured as input. Now we'll start our while loop. That is while 1 and we'll write our while loop between these two braces. We can also initialize different variables before while loop, like SSFLG equals to 0. Here we have initialized the start stop flag before while loop. We can also write an initialization subroutine instead of initializing the variables in void main. So here we can write ini underscore r is the name of initialization subroutine that we will use in our program. So I'll write the initialization subroutine before main program. Here I will write initialization subroutine. Now here I will write initialization routine, that is ini underscore r is the name of initialization subroutine, and here we will write all the variables which are required to be initialized in our program. So first I'll initialize start stop flag here, and I'll cut this line from here, that is from void main, Control X, and I'll write this line in initialization subroutine, Control V. So whenever our program will start, so before coming to while loop, it will call initialization subroutine and it will initialize SS flag. Now here in while loop, first we will call a subroutine, that is switch routine. So we'll write here, that is SWR, and here we can add comments, that is switch routine, and we will write the switch routine after initialization subroutine here. Now here I will write switches read routine, so I can write SW underscore R, and here we have our subroutine to read the switches, and here in the subroutine we will read the status of switches which we are using in our program. So I'll go to the help, and in MikroC Pro for pick libraries, I'll go to button library, and I'll copy these two lines from the sample program, Control C, and I'll paste these lines here in subroutines, which is switches read routine, so Control V. Now we'll modify this function according to our hardware. Here we can find the port B is used in this function, but we have connected all 4 switches on port D, so I'll change the port here, and here we can see we have assigned the name to port D, that is switch port. So I'll copy this name from here, Control C, and I'll paste it here, Control V. Our first switch, that is switch 1, is connected on port D4, so I'll make this number 4. This number represents a debouncing interval. Here in this function, debouncing interval is 1 millisecond, and we'll change it to 50 millisecond. And here we can find the active state of the switch. In our case, all 4 switches are active low, so we'll change this number by 0. and here we will also change the comments, that is detect logic 0. Now we'll modify this line according to our program. Here we can see we have defined a variable that is start stop flag. So we'll set the start stop flag here. So I'll copy start stop flag from here, Control C, and I'll paste it here, Control V. And I'll also change the remarks on this line, that is set start stop flag. Now here I'll close the function. Okay, this function is completed. Now we can understand the function that if the switch which is connected on port D at port D4 with the debouncing interval, if the switch will go to 0, then SS flag will be 1. Now we'll copy this function, Control C and Control V here, and we'll change the port number, that is 5, and we'll change the comments here. We can write at port D4, and here we'll write at port D5, and we'll change this line to 0. If switch 2 is pressed, it means the switch which is connected on port D5. If that switch will be pressed, so SS flag will be 0. So here we have written a subroutine, that is switch read routine. Now we'll go to MikroE libraries, system libraries, and I'll select button library. Okay, now if I'll compile my program, these errors will be removed. Okay, here we can find that there is no red line under this button function. Now we'll call some more subroutines, that is counter routine, counter R, and we'll add comments here. Counter routine, and here I'll write counter routine before main program. Now we'll write counter routine here. We'll write counter routine between these two braces, and here we'll write that if SS flag equals 1, then our program will come between these two braces, and here we can increment the counter register, that is counter reg ++. In our previous program we had written a command, and it was delay underscore milliseconds 500, and to execute this delay function, program will stay for 500 milliseconds in this function and will not be execute any other command which is written in our program until the completion of this function. But here in this program we will not use this delay function, and here we will make this line as comment. Now we'll write a delay subroutine, and we'll call this delay subroutine before counter routine. So here I'll write DLY underscore R is the name of the delay routine which we will call in our program, and we'll add comments here, that is delay routine. And we'll write the delay routine before main program, and here we'll write the delay routine, that is DLY R to produce a required time delay. We'll assign a variable in our program, and here we'll define a variable that is unsigned integer. As we know that the length of character is 8-bit and the length of integer is 16-bit. and an unsigned variable can go from 0 to 65535. So we will assign the name to our variable, that is delay register. Delay reg equals to 0. Here we have initialized the delay register to 0 value, and we will add comments here, that is delay register. Now we will use this delay register in delay routine, and here we will write, that is if DLY REG is less than or equals to, say, 1000, in this case we'll increment delay register and we'll write DLY REG plus plus, and if the value of delay register will be greater than 1000, then our program will not come into this if statement. So we'll write a new if statement, and here we will write if DLY REG is greater than 1000, then our program will come into this if statement, and here we will set a delay flag in this if statement. First we will define our delay flag. Here we will define the delay flag, that is bit DLY FLG is the name of our delay flag. So we'll add comments. Delay flag, and we'll also initialize this delay flag to 0 in our initialization subroutine. So I'll copy delay flag from here, Control C, and I'll paste it here, Control V, equals to 0. Now this delay flag will be initialized during initialization subroutine, and here we can write if the value of delay register will be greater than 1000, then set the delay flag, that is DLY FLG equals to 1, and we'll reset delay register. So we'll write here DLY REG equals to 0. So our program will not come into this if statement until and unless the value of the delay register will be greater than 10,000. Now we'll use this delay flag in our counter routine, and we can write here that if delay flag equals 1, then our program will come into this if statement, and it will check if the SS flag will be 1, then it will increment the counter. Now we'll close our if function here after this bracket, and if delay flag will be 1 and SS flag will be 1, then our program will execute this line and counter will be incremented by 1. After incrementing the counter by 1, we will reset the delay flag, that is DLY FLG equals to 0. Here our program will come in these two if statements. If delay flag will be 1 and SS flag, that is start stop flag, will be 1, then the counter will be incremented by 1 and delay flag will be 0 after executing this line.